So we are talking about UML today. We are talking also about flowchart. So it is only not only a graphical representation. Uh, you have to relate it with your scenario. Basically, what happens in flowchart? Whenever you have your program, then you try to represent how your flow of control will be from start to the end. In between, it may come through the different portion where it has to take inputs, perform something with input output. It has to perform some internal processing. It may have certain control loops. It may have to go for a loop, or it may have some decisions to take. So you have to represent these things in flowchart. From these few answers of 2-3 students, what I was able to understand is you were not much aware of flowchart as well. Am I wrong? Uh, Rituraj,
Yes, sir.
can you tell me something about flowchart that we are talking currently?
Sure, sir, but just joined. It was a graphical representation, as he told.
Okay. After that, I also told something, and you may be knowing something from earlier.
Sir, it is a representation like if it is a complex something, so we make it in a stepwise process to make it like sort. Yeah.
Okay, no issues. I understood one thing that I should also tell about the flowchart. So since we have started UML, we will see UML and then we will see flowchart as well. Uh, are you aware of ER diagrams?
Yes, sir.
Ajit Singh is saying something about ER diagrams. Can you say a little more about ER diagrams? What do we represent there?
Sir, we represent the entities and relationship with other entities.
What are these entities?
Sir, entities like to store some information, and we have attributes attached to entities. Attributes are the properties of entities.
Okay. Okay. So what Ajit Singh is saying is ER diagrams are something that we usually build, usually model at the time of database design. Okay. So how actually your database will be? We consider each table, I should say, each relation as an entity, and this entity will have certain attributes. Okay. So these few things and how these relations are related with other relations, there is something we call it relationship. Okay. So for all these things we have a representation. Okay. Some of them you will see, some of them are oval, some of them are rhombus. These all the things will represent something. Okay. So what I was able to understand by Ajit Singh that you may be aware of a little. So we will also go through ER diagram very quickly so that you could brush up. But still, let me ask some other people like Rajesh Kumar. Rajesh, what do you think
Sir,
about ER diagrams?
so AR diagrams are entity relationship for the database design.
Okay, so do you know it? Uh, how to model ER diagram?
Yes, sir.
Okay. So can you tell me what is the representation for a relationship?
Representations. So strong relationship are represented by the kite symbol,
Yeah, we call it rhombus. Okay.
rhombus, and weak or identified relationship is represented by double rhombus symbol.
Okay. Somehow what I understood is you people may be aware of ER diagram. But the thing is, as a software developer, we should be aware of all these things, right? So while discussing here something about class diagram, I will try to discuss about it, but I don't know here I will be able to use my pen still. Okay, so let us talk about UML here. We are talking about the object-oriented designs, and here we are talking about UML. So UML is a modeling language. Modeling language means where you will try to express your design. Okay, you are not coding using this UML. It is just a way of showing that this is how your system will look like. Okay, unified modeling language. It is not a coding language. It is just a representational language, you should say. Okay. Okay. So it is also independent of any implementation language. Why do we use this UML? Because it has graphical notation, as well as it is also open standard. Something which is of open and standard. When we call it a standard, when most of the people, all of the people throughout, they are able to understand it and adopt it in their work process. Okay. So here we are talking about language that can be used from general initial design to very specific detailed designs. All these things, whatever we think, we can do it with the UML. Now, if you want to design this UML diagrams, there are several software packages today. It may comes with rational. We have rational rows. Other than that, we can have some plugins with NetBeans and Eclipse also. And not only these, we have nowadays several packages, software packages available online for our UML diagrams. Okay, so we have already seen that this was started in 90s. Okay, these all the peoples are there who have contributed, and organizations as well, those who have contributed to our UML, no problem. So let us see something about system, model, and views. This thing, when we are talking here about system, models, and views, this you should not be confused with any other model views that you would have seen in your other technologies like React or Django or these kind of things. Okay, here it is just an abstract, different thing. It is not related to model view component or model view template. Okay, so here what we are trying to understand is model is an abstraction describing the subsystem of a system. View depicts the selected aspects of a model. A notation is a set of graphical or textual rules for depicting the views. Okay, let us see the example. It will help us understand. So if it is a system that is aircraft, then the models can be flight simulator, scale models. In flight simulators, suppose you may have certain smaller portions. Okay, they can be considered as views, like electrical wiring, fuel system, this kind of other kind of operations that are going on. So they can be considered as separate views. Suppose this is your system. Okay, so in this system, suppose there are certain modules. System is aircraft, then these are the modules. This is a scale module, and this is flight simulator module, and they will have certain views. Okay, the blueprints and electrical wiring and other things. So, having understood about these, let me tell you about a little more about these things. Each diagram is a view into a model. So, what here we are talking about is, in UML we try to have a diagram for each smaller portion, as smaller as possible we can have. Okay, so each a large system can be divided into models, and these models can be again subgrouped into views, and these views should be such a smaller, which could be represented in one diagram, right? So for each view we try to have a diagram. Okay, so it provides a partial representation. It should be semantically consistent with other views. We are talking about logical views, implementation views, deployment views, and process views. All of these can be considered as use case views. However, these views may be related to different users, and it may be related to showing a different aspect of the system. However, they are showing the same view. Okay. So end user needs to know, needs to understand about according to the functionality. Programmers needs to understand according to the software management, and system integrators, they will also try to understand about the performance, scalability, and these few things. Deployment view will tell you about the system engineering, where mainly system topology, delivery, installation, how these all thing can be done, where it will be, how it will be deployed, what are the things will be. Accordingly, some diagrams will be needed to be uh, mm, designed. Okay, so here we are able to see about certain views of the same model. You will have class diagrams, object diagrams, these kind of different things. So some of these diagrams will be considered as static views. Some of the diagrams will be considered as dynamic views. Okay, it's like here you see class diagram. Okay, use case diagram, component diagram, okay, object diagram as well. We are considering them as static. However, these site collaboration diagram, state transition diagram, sequence diagram, activity diagram, these will be considered as dynamic diagrams, dynamic views, where we usually show according to the situation that if some event occurs, what is there that will happen. However, in static diagrams, what we do, we just show the actual thing, that these are the classes or these are the objects, they are related to each other, these functions are there, these functions can be called, and these will be the output kind of thing. Okay, having known about these things, we have to understand how many views. We will talk about these diagrams now. Before that, let us talk about how many views we should have. So it can be judged according to the situation and the need of our current project, right? So suppose we are using the single processor, then in that case you may not think about deployment views. Okay, multiple processes are not there, single process is there. You can also remove the process view. You can just carry on with your what was the first view according to that logical view. Okay, If it is a small program, then you may not worry about the implementation views as well. So accordingly, according to the need and complexity of your system, you may think about the views that you may need. So what we think is you can model 80% of the most problems with 20% of the UML. What we are thinking is, as we have seen, there are multiple diagrams in UML. So a few of the diagrams only may be enough to represent 80% of your needs. Okay. Use case. Use case diagrams will be helpful for understanding the requirements. While requirement gathering also, we have gone through it that there is something called use case diagram. If we get the requirement from the user and make a use case diagram, it will be helpful. Here we will see actually how the use case diagram can be built. Okay. So domain model, capture process and key classes, capture design model, capture details and behavior of use case and domain objects, add classes that do the work and define the architecture. So what are these? First is use case diagram, another is class diagram, package diagram, interaction diagram. In interaction diagram, we may have a sequence diagram and collaboration diagram, activity diagram, a state transition diagram, and deployment diagrams. So we will see these diagrams here. Let us start with use case diagram. Okay, till now, is there something that you want to want some clarification on? Okay, in that case, we can continue with the use case diagrams. So basically, what happens in use case diagram, your functionality, whatever functionalities are there, you want to have, they will be considered as your use cases. Okay, and there will be certain external users, they will be considered as actors. So here, these actors are there, which will represent like this. This representation is for actor, and this oval thing is your use case. Okay, suppose it is purchase ticket, so it is a functionality that your system should have. So you represent your functionality in a oval. So this is your use case, and this is the actor. So we will see the actual use case diagram as well. But here what you have to understand is these are the actors or the external users who will interact with the system. And while interacting, they will try to use some functionalities. These functionalities will be represented in this oval. Okay. 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 The use case model is a set of all use cases. Okay. It is a complete description of the functionality of the system and its environment. So actors. So actors can be the users, external system, or physical environment. What are these? Users, you will be able to understand that they are the certain type of user which will interact with the system. Sometimes our system may be interacting with other external systems as well. So they may also be considered as one of the actors, because they are somehow interacting with our system. They are using some of the functionalities, or they are affecting some of the functionality. Physical environment, it may also affect the functionality. Because of that, what we are doing, we are keeping it also as an actor. So every actor here, you will have a unique name, whatever it has, and you may have also some description if you want to keep. Okay. So, for example, a passenger, and description is something like a whatever a person who is traveling. GPS satellite. Okay, this is an example of external system. Okay, which provides the system with the GPS coordinates. So now use cases. Use cases will be represented by this oval, and it will represent a functionality, one functionality that is being provided by the system. Okay, so use case will have its unique name, and it may be uh, interacting with the actors. So you may note down who are the participating actors, what are the entry conditions. We have an example, we will see it. What is the flow of events, and what will be the exit conditions, and if there is some special requirement. I believe you may remind some of the things while your structured requirement gathering, right? There also you try to gather the requirement in a way like what is the name, and what will be the entry condition, what will be the flow of event, and what will be the exit condition. Few important things, right? So this few things, if we are able to write along with this functionality in a structured way, this will be helpful for the constructors, or means the actual implementers, to understand the requirement. Okay, see this example of a use case. One use case is purchase ticket. So who are the participating actors? Passengers are those who will interact with the system to book their ticket. What are the entry conditions? Passengers are standing in the front of the row, or if at all it is a system, it should be something like they have logged in, and whatever something kind of entry conditions will be there, right? Passengers should have sufficient money, or whatever entry condition according to our system is, we can keep. Now, what will be the exit condition? When the system, when he exits, when this process, this functionality is executed, purchase ticket, passenger will have a ticket. What will the event flow? Passenger selects a number of zone to be traveled, distributor displays the amount, passenger inserts the money, distributor returns changes, distributor issues tickets, and similarly other things can also be there. Do you think there are some other things that should be included here in any of the places, entry, exit, or event flow?
Sir, if the passenger is not allowed,
Okay, so those conditions are not included here, right? Like if the passenger was not having the sufficient money, like the passenger was not fulfilling some of the criteria to book the ticket, right?
yes, sir.
So I believe you are talking about the exceptional cases. So some cases may arise where he may not be allowed to book the ticket. In that case, passenger may not get the ticket on the exit. So there is something that we can represent here with extends keyword. Okay, there are other functionalities. Whenever it is an oval, you can understand that it is a use case, it is a functionality, but this functionality is being used by another functionality. Okay, so this use case, purchase ticket, is using these functionalities, but in exceptional cases. Okay, what are something there is out of order, if it needs to be cancelled, or there is something no change kind of thing, whatever, money is not there, or some timeout occurs. So in such cases, such functionalities will be used here. Okay, but these functionality will not be used always. So we have to decide for these functionalities also, and for these functionalities we can keep separately with a extend keyword. Okay, I should say extend relationship. Okay, which shows that this functionality is being extended. So let me remind you that this extends is being used only for the exceptional cases. However, you might be thinking about, sir, why only exceptional cases? In exceptional cases, we are keeping some of the functionalities separate. We have heard about code reusability. If at all, we can divide some functionality into a smaller portion and we can keep it separate, then it will be helpful and it could be used in another functionalities as well. Okay, so in that case, we can use includes relationship. Okay, what happens here? You can see this purchase single ticket is one functionality, is one use case. So it includes collect money portion, because I have kept this, means we can understand that collect money is kept separately because it can be used for other use cases as well. So this collect money has been kept separately, which can be used by this thing. But here it is includes. Includes means it will always use this collect money use case whenever it is not having any exception. Okay, however, collect money may have certain exceptions, like there is no change, or it needs to be cancelled or some whatever. In that case, it is using, see, extends. However, in such cases where it is always using collect money, it is using includes. Okay, you can see that when this use case purchase single ticket uses this collect money, then the arrow is on collect money side, and here when it is extended, then no change is being extended towards collect money. Arrow is on collect money side. Okay, so having understood about these few things, I believe once we are aware of these things, we can design the use case diagrams easily. But one thing was that when we have a use case diagram, we try to have all the use cases, all the functionalities to be represented in the diagram. Okay, I'm not saying that we have to use the single page only. However, if we are able to make it on a single page, that is better. But I understand that the requirements are much diverse, and you may not be able to represent all the this thing functionalities on a single page. So you can have multiple pages, and the thing is, what you are showing is these are the use case, and these are the actors who are interacting to it. And if this use case is also interacting with other use cases, these use cases are those which you are going to implement. Okay, if there is something which is external, it should be represented as another actor. Okay, okay, so you have to determine the requirements. According to the requirement, new use cases can be generated. So for each functionality, you will have a use case, and accordingly, you will have to find out who are the users who are interacting with this use case, so they can be kept as a actor. For this, you will be having to communicate with the clients, and accordingly, you will generate the test cases also. Generating test cases means it will be easy for you, as you will see this use cases. You can also analyze that what was the entry and exit condition. Accordingly, you can design the test cases that in certain scenario, what should happen and what actually happened, right? So in test cases, what we keep, what should happen, right? Okay. So, so we have discussed something about the use case diagrams, which represents the external behavior. Use case diagrams are useful as an index into the use case. Okay. So these are the few things that we have discussed here in use case diagram. Now let us see something about the class diagram. Do you have anything to be explained in use case diagram till now? Okay. Sashikant. Sashikant, are you there?
Yes, sir. Yes, sir.
So in a use case, when do you use this extends keyword, extend relationship, I should say? Sashikant? Sashikant? Shashikant? Shashikant? Shashikant?
Yes, sir. Yes, sir.
Huh. So when do you use this extend keyword?
No idea, sir.
Huh. Where were you?
Yes, sir.
Huh? Are you, I mean,
I don't. I don't understand properly, sir.
okay. Suraj Kumar.
Yes, sir.
So can you tell me when do you use this extend keyword?
Sir, uh, when the user is interacting with the system, sir.
Okay. Okay. Shivam Kumar.
Yes, sir.
So did you understood something about this use case diagram?
Yes, sir.
When do we make this use case diagram? Shivam.
Yes, sir. I'm listening.
Hmm? Hmm.
Sir, when we have to analyze like in passenger case to purchase ticket, we have to
Okay.
सर जब कोई काम कैसे करना है उसको देख कर लाइक एक एक्टर लाइक एक्टर लाइक पैसेंजर वो देख कर हमें यूज केस डायग्राम बनाना है
Achha. Aryan Beast.
Yes, sir.
So when do we make this use case diagram?
Sir, we make use this type of diagram when we want to show just a high level. We don't have to show all the processes or every single implementations. When we are just showing how the main system will work, the main functions only.
Mhm. Chavi Rana,
Yes, sir.
can you tell me about this thing, use case diagram? When do we make this use case diagram?
Sir, to give a overall, to describe the overall architecture of system components, sir. Basic.
This is class diagram. We were talking about use case diagram.
Sir, use case diagram is used to give a high level description of the whatever project we are making, sir.
Okay. Okay, let me try to summarize it again. What happens actually, use case diagrams are designed at the time of requirement gathering only. When you are gathering the requirement, you are talking to the clients and trying to understand what actually they want in the system. They used to tell that these are the functionalities that we want, and this. You said, wait a minute. What we do, let us talk about each of the functionalities separately. Okay, one functionality is one use case. Okay, so you may have hundreds of functionality, no issues. Hundreds of functionality means hundreds of use cases. Okay, let us talk about one use case. Okay, one by one we will keep on talking about the several use cases. So whenever we have this use cases, first use case we are taking and we are talking about it. Okay, tell me, for this functionality, for this use case, who are the actors? Means who are the users who will interact with this functionality, who will use this functionality of the system. Okay, so they are considered as actor. Let me repeat, the users who will interact with the system, they are your actors. So what you do, you keep your actor as this. Okay, this is your actor, they are interacting with your use case. Okay, these things are optional. It may be in your diagram, it may not be, but this thing is mandatory. There is a use case and there is an actor who is interacting with the use case. Okay, now these actors, as we have seen, there were three types of actors, right? One was the user who is going to use this functionality, and two others were external. One was external software modules. If they can also interact with this particular features, particular use case. They can also be an actor. There can be other environmental factors. The whole environment can be one of the actor, because of which this feature may be affected, right? So they can be considered as actors. and then this is the use case. So let me try to understand, is it clear till now, right? Gunjan Kumar.
Yes, sir.
So till now we have talked something about use case diagram. What were you able to understand?
Sir, this is about, sir, about a system which may have several functionalities. It is it is to show about a particular functionality and the interaction with a particular user in it.
Particular functionality and the user in, yeah, kind of.
It shows about how the user interact with that particular functionality in the system and in details.
Hmm. Yeah, very good. This is what we depict here. That this is a functionality, and this is the these are the users who are going to use it. This in your diagram you may have another functionality, another use case, and which are the users who are using it. It may be the same user who will be using this thing, this use case also. So in your entity relationship diagram, sorry, in your mm, use case diagram, you will have functionalities. Each functionality is a use case and the actors who are interacting with those functionality. Very simple. This kind of use case diagram is made during the requirement gathering phase. You are continuously talking to the clients and trying to understand the means client or other stakeholders as well, and trying to understand the requirement. And to write the requirements, you would have seen several ways, that there was a way of writing a structured way or some natural language way. We can write the requirements. This is also a structured and graphical representation of writing your requirements. Here we are not talking how actually this feature will be implemented. We are just talking about what these features, what we can expect from this feature. Okay, so this feature will be implemented by some of the developers, so they should understand the requirement. So this feature will be used by this set of users. Okay, so what we do is we write, where it is, we write a use case something like this, that this was the use case, these are the actors who are participating who can use this feature. What will be the entry condition? That the passenger should be logged in and passenger should have this thing, that thing, whatever it is, and then they can use this functionality. And while using this is the steps. Okay, according to these steps, there are when these steps will be completed, there will be exit condition, that on exit what should happen. Okay, so this is
Sir, sorry to interrupt. So actually, we have class right now of mathematics.
okay. Okay, no
Yes.
problem. Today we have talked about use case diagram. Now you people can leave, no issues. We are not going to talk anything about class diagram today, only use case diagram. Okay.
Thank you, sir.
Yeah, so those who are here, those who don't have class, let me clear to them that use case diagram here, we discussed about the functionalities which will be noted down during requirement gathering phase. Okay, very simple to understand, that you will show this as the users, and these are the use cases. Users are using this use case. This is something that you have to represent. And according to the system, you will have multiple use cases, multiple functionalities. So all those functionalities should be represented in your use case diagram. That is the simple thing. Do you have any question related to this? Pawan Kalyan. Pawan Kalyan. Okay, no issues. Okay, Pawan Kalyan is there, but he may not be able to say anything. It's okay. Durga Prasad.
Yes, sir.
So can you tell me, when do we make this use case diagram? Okay. So any of you, can you tell me when do we make this use case diagram?
May I, sir?
Yes, please.
So use case diagram basically lays out the interaction between the actor and the system.
Okay. And when do we make this diagram? My question is, in which phase of our software development life cycle we make this use case diagram?
Sir, while we are hearing about the requirements, we make these use case diagrams.
Yeah, so it is while gathering the requirement. While we are gathering the requirement, then we make this diagram, where we are just noting down what are the functionality and who will be the users of them. Okay. Okay. Then you use extend keyword when some exceptional functionalities are being used by other functionality. In that case, you use extends keyword. That it will be used sometimes in rare situations. Okay. Then extend keyword. And in some cases like collect money, which will be used always in normal condition, then we use includes keyword. Okay. So this is very simple few things about the use case diagram, and I believe you can make the use case diagram. Okay, next class we will see about class diagrams and other possible diagrams. Okay, any questions till now? Okay, then I believe we can stop here.